Hello again, this is Gary, and we're going to continue with our digesting drawing series. Today we're going to look at a DC elementary, 115 kV DC elementary for breaker 3B62 closed circuit. So of course, we're going to look at the preliminary PE stamp, name, drawing number, revision, make sure it matches here, and in the transmittal, pay attention to the legend and any notes. So this circuit's a little bit more involved, so we're going to start with this right here. You're going to see these tables. Whenever you have a selector switch, like for example, this 52 MCS says close, you're going to have a table that details the contact positions per stack. So what does that actually mean? Well, I have a picture here. This is an example of a selector switch with multiple stacks. This would be stack 1, 2, and 3. Okay? So when they refer to stacks, they're referring to these stacks. Let me pull up the right page here. They're referring to these stacks on the breaker control switch. Okay. Now, you're going to notice as well that they talk about the position on the 52 MCS switch. There's a trip position, a closed position, and then there's a normal AT and AC. So what does that mean? T means trip. So what does that mean? That means when you trip the breaker, which is you take the breaker control switch, which is this, and you turn it to the trip position. See, there's the trip. That means you rotate the handle so it's in the trip position. These contacts on these decks will close where there's an X. And when there's no X, the contact is not closed. So they use this for all kinds of logic. That's basically what it's used for. So all these additional contacts. If you put the position, trip is basically means open. If you put the breaker control switch into close, which means you turn it this way, then these contacts on these decks will close. See that? That's basically what this table explains. Now this normal AT, the way you read it, is normal after trip and normal after close. So what that means is when you have your selector switch into close, when you turn the handle into close, the indicator here is green. It's called the semaphore. Will go from green to red. And when it goes to red, the normal after close then is energized. That means these contacts on these decks will be closed when the red semaphore is present. Okay, so you're in the trip or open position. You turn the handle, you see a green, you turn the handle to close. When the handle's turned to close, these contacts will close, and then the normal after close contacts will also close, indicated by the red semaphore. So therefore, if you trip the breaker, you turn the handle, it's now in red, and you turn it to trip, the red will turn to green, and the breaker will trip. These contacts will close, and then the normal after trip contact, which is indicated by the green semaphore, will close. You may have to replay that a few times for it to actually make sense to you. Okay, but this is important to understand. You see this used a lot in the industry. Normal after trip and normal after close. And this explains how it works, along with the diagrams I just showed you. That's it. We're going to continue now to part 2.